Hello guys, this is prime concept. So we have another problem under electrostatics to handle. I'll still solve this problem in two methods. So let me start with the first method, and in the next video you would see the second method. Just above this video you'll see the second method, so you try to follow the first and second method to understand. Now we have two equal positive point charges. So take note, they are equal. The two charges are equal and they are both what? Positive. Point charges Q1 and Q2 equals 2 microcoulomb are located at x equals 0, y equals 0.3, and x equals 0, y equals minus 0.3 respectively. So what it means is that Q1 is located at this point, x equals 0, y equals 0.3. So when you have x as 0, it simply means that that thing is along the y-axis. If y is 0, it means that that thing is along the x-axis. So the concept is clear. So since x is 0 for Q1 and y is 0.3, means we are along the positive y-axis. So this is my 0.3 meters. So this is where I have my Q1, right? This is my origin. This is my origin. So this is where I have my Q1. Then they said Q2 is at x equals 0, still along the y-axis, but y equals minus, so negative y-axis, which is down. So which is down. So this is my negative y-axis. So this is what now? Negative. So minus 0.3 meters is what I have. So this is my Q2, right? Now, then we have, the question says, what are the magnitude and direction of the net force these two charges would exert on a charge Q0? So we have a third charge. We want to find the magnitude and direction that Q1 and Q2 would exert on the third charge. Now let's check, where is this third charge located? The third charge is located at x equals 0. Oh, sorry, x equals 0.4. And then y equals 0. So meaning that this is along the x-axis, the positive x-axis. So this is where we have the third charge, 0.4. 0.4. So this is where we have that third charge, Q0. So this is the solution diagram. So I'll be using the unit vector concept to solve this. Now let me quickly write out my charges. Q1 is 2 times 10 to the power minus 6, which is given here. Same thing as Q2. 2 times 10 to the power minus 6. Then our Q0, which is this, is 4. So 4 times 10 to the power minus 6. So we have our charges, so I can rub this. Now, we have, for us to find this force, the net force and direction, we have to join these charges. So we have to join this to this, join this to this. So this will give us this, because we are moving from this to this. This will give us this, because we are moving from here to here. Remember, this is your source. This is your test. This is positive. So which is repulsive force away from your source. This is your source. This is your test. And both of them are positive. Repulsive force away from your source. So this is what you have. Now, one thing we want to do is to find R1, R10. R10, that is that distance. And we also want to find R20, this distance. So let's do that very quickly. R10 is going to be, now watch, this is where you are, this is where we are, and we want to get to this point. So we can go like this, which is R10, or we can come down and then go like this, the same thing. So when you come down, this is going to be negative because you're moving against this arrow. It's going to be negative 0.3. Remember, this is your y-axis, so it's J, right? Then you are at this point now, you move like this in favor, in the same direction, so it's positive 0.4 I, right? If you were to rewrite this, so this is going to be 0.4i minus 0.3j. So these are our R10. Now what is the magnitude of R10? The magnitude is simply going to be 0.4 square this. So when you solve this, it's going to give us 0.5 meters. And the next thing we want to get is R20. So without watching this, pause the video and try to find R20 so that we can be sure you're following. Then you play it back and check if your answer is correct. Now R20, this is where we are at position 2. So we can move like this to put Q0, which is R20, or we can move like this. Remember, we're moving, since we're moving like this, we're moving against this arrow. So it's going to be what? Negative, right? Now, it's going to be negative because we are moving against the arrow. Remember, this is already carrying negative. So negative of negative 0.3, right? Then when you are here, you move like this in same direction. So this is positive plus 0. This is j, 0.4i positive, right? So if you rearrange this, you will have R20 is going to be, let me write this first, 0.4i. This becomes positive, so plus 0.3j. So this is what we have, right? Now I want to find the magnitude. R20 magnitude. What is it going to be? The same value, so it's going to be 0.5 meters. When you do the magnitude, it's still going to be same thing. Now I'm going to rub that diagram so I will have space to solve, right? So I want to get my unit vector R10. The unit vector R10 is going to be R10 divided by magnitude of R10. So this is the formula for the unit vector. So which is going to be what now? R10 is 0.4i minus 0.3j divided by the magnitude is 0.5. So if I solve this, I would have 0.8, I think. Okay, 0.8. 0.8i minus 0.6j. So this is my R10 unit vector. Now my R20 unit vector, same way, is going to be, what is my R20? 0.4i plus 0.3j divided by 0.5. So if I punch this, I'm still going to get 0.8i plus 0.6j. So that is the unit vector. I'll still need to rub because my board is quite small. So the next thing I want to quickly do is to get the force, then multiply by their unit vectors. So my force F10 now, F10 is going to be what? F10 is going to be K. I don't have to write the formula again. So it's going to be K, Q1, Q0 divided by the distance. Okay, let me just write K, Q1, Q0 divided by R10 divided by this. So if I do this, I would have K, 9 times 10 to the power 9, Q1 times 10 to the power minus 6, Q0, 4 times 10 to the power minus 6, divided by R10. R10, okay, R10 is 0.5, that's the magnitude, 0.5 square. So I have this. So what do I have from this? 9 by 8. So this is 0.29, 0.29. Now, of course, you know that F20 is also going to be 0.29 Newton because both of them are equal. They are equal. Now, the next thing we want to do is to multiply these forces by their direction, by their unit vector. So I will have F10 is going to be 0.29 times the unit vector. What is the unit vector? 0.8i minus 0.6j. So if I solve this, I would have 0.29 times 0.8 is 0.232i. 0.29 times 0.6. So this is 0.174J, right? So this is my F10. I will still need to rub this. So try to always take notes while you're watching this video. It will help you. So I've gotten my F10 in vector form now. The next thing is F20 in vector form, which is going to be 0.29 into my R20 unit vector is 0.8i plus 0.6j. So if I expand this, I would have 0.232i, and this times this, I would have plus 0.174J. So this is what I would have as my F10 and my F20. The next thing I want to do is to find the net force. The net force is going to be F10 plus F20. So that is going to be our net force, right? Just a direct addition for both of them. So if I add both of them, F10 is 0.232i plus, minus 0.174j, then plus my F20 is 0.232i plus 0.174j. So if you add up these two things, if you add them up, you notice that this would fizzle this, because this is minus 0.174, this plus 0.174, it will go to fizzle out. Then these two would add up. So let me quickly add them. 232. So this would give me 0.464i. So this is what I have. And of course, the magnitude of the force, this is my force, just it has only x component. And of course, the magnitude of this force is still going to be 0.464 Newton. So that is the answer. That's the magnitude of the force. Then the next thing we want to solve. So the magnitude of the force is 0.464 Newton. From here you can see it has just I. So it means that the force is pointing in what direction? Positive x direction. Positive x direction. And the magnitude is 0.464, pointing in the positive x direction. I believe this concept is very clear. Thanks for watching my video. I'll be solving this same problem using another method in the next video. So try to follow it and then choose which method is clear or well explained to you. Thanks. Do subscribe to my channel, like my videos, and share with your friends so that they can also benefit. Remember, this is Prime Concept.